Volume of cylinders. The decorative rain gauge shown is shaped like a cylinder. It has a height of 13 centimeters and a diameter of 3 centimeters. How much water can the rain gauge hold? To find how much water the rain gauge holds, find the volume of the cylinder. The formula for the volume of a cylinder is V equals pi times R squared times H. The rain gauge has a height of 13 centimeters and a diameter of 3 centimeters, but we need to know the radius to use the formula. Recall that the radius is half the diameter, so the radius is 3 divided by 2, or 1.5 centimeters. Now we can use the formula. Replace R with 1.5, H with 13, and pi with 3.14. Simplify. So the rain gauge can hold about 91.8 cubic centimeters of water.
This is Mrs. Workman. Find the volume of the cylinder. Round to the nearest tenth. We remember that the volume formula for a cylinder looks like this: pi times R squared times H. If part of that formula looks familiar, the pi R squared part, then you're right. You're probably thinking, I've seen that somewhere before. That's the area formula for a circle. And if we look at our cylinder, we notice that a cylinder is really just a stack of circles, all the same size. So we're taking that stack of circles and we're finding the area of those, and then we're multiplying it by the height, which tells us how many circles are stacked on top of one another. That just might help you make sense of this kind of strange looking formula. Okay, we need to know the radius of the circle, which we're given as 3 yards, so we know that. And to use the formula, we must also have the height of the cylinder, and we're given that as 6.4 yards. So now we're going to go back into the formula. And again, I'm going to rewrite this: pi times R times R times H. And now we'll make our substitutions. In place of R, we'll put 3 yards. In place of R, we'll put 3 yards. And in place of H, we'll put 6 4/10. Picking up our calculator, we're going to multiply pi times 3 times 3 times 6.4, and we're going to get a value that is about 180.9557 and so forth. Now, our instructions tell us to round the answer to the nearest tenth. Here's the 10th position. It's followed by a 5. So if we round this off, it becomes 181.0 using our rounding off rules. So let's see if we can pull this all together. Using the volume formula, we found that the volume of this cylinder is about 181 0.0. Now what about the units? The units are yards, yards times yards times yards, or cubic yards.
Hello, I'm Mr. Adams. Today we're going to find the volume of a cylinder. Find the volume of a cylinder-shaped bucket that has a diameter of 10 inches and a height of 12 inches. All right. In order to find volume of a cylinder, we use the formula volume equals pi times radius squared times the height. And we can do simple substitution to find the volume of this particular bucket. So the volume equals pi times the radius squared It says the diameter is 10 inches, so the radius is 5. The radius is always half the diameter. So 5 squared times the height, which is 12. So we have volume equals pi times 5 squared times 12. We can do some simplifying. So volume equals pi times 25 times 12. And you can use your calculator to help you out with this one. And our volume is going to be about 942.5 inches cubed.
This is Mrs. Dawson. Find the volume of each cylinder, round to the nearest tenth. Radius of base 8 inches, height 20 inches. Diameter of base 12 4/10 centimeters, height 13 3/10 centimeters. We'll begin with the green cylinder. Notice we have a radius of 8 inches that is halfway across the circular base and a height of 20 inches, and that is the distance between the two circular bases. The formula to find the volume of a cylinder is big B times H. Big B stands for the area of the base, and H represents the height of the cylinder. The area of the base in a cylinder is a circular shape, so we'll replace big B with pi times radius squared, and then multiply by the height. The radius is 8, and the height is 20. Since we're rounding to the nearest tenth, we'll have an approximation of pi, or 3.14, times the square of 8, which is 64, times the height, which was 20. So the volume of this cylinder is approximately 4,021 2/10. Our units will be cubic inches because the radius was in inches and the height was in inches. Volume will be in cubic inches. The second cylinder is situated a little differently. However, we're given the diameter as 12 4/10, which means the radius is exactly half that, which would be 6 2/10 centimeters. The height is the distance between the circular bases, and in this case, it's 13 3/10 centimeters. The formula, once again, is the area of the base, big B, times the height of the cylinder. It's a circular base, pi times radius squared, times the height. The radius in this case was 6 2/10. We'll need to square that, and then multiply by the height, which was 13 3/10. Using 3.14 to approximate pi, the volume of this blue cylinder is 1,605 3/10. The units in this case would be cubic centimeters. The area of the base would be in square centimeters, and then the height is in centimeters, which gives us the volume in cubic centimeters.
Hello, this is Mrs. Hyman. Recycling. Find the volume of the recycling bin shown. Well, if you take a look at the recycling bin, it looks like it's made up of a rectangular prism and half of a cylinder. So what we're going to need to do is to find the volume of the cylinder and the volume of the prism and add those two together. So we'll start first with the cylinder. Well, volume of a cylinder, the formula is pi r squared times h. But since we only have half of a cylinder here, what we're going to use for our half cylinder is going to be half of that formula, so 1/2 times pi times r squared times h. So now we need to look at our drawing and find those measurements. So we need r, which is the radius, and the radius would be from the center out. That would be a radius. So to find that length, we're going to think about the length of this side here is 2, which means the top is also 2 feet, and half of that would be the radius. So our radius here is 1. And then we also need the height of the cylinder. The height of the cylinder would be across here, and this length should be equal to the length at the base. So that is also 1. So the height of our cylinder will be 1. So now we can find that volume. 1/2. And in place of pi, we'll use 3.14. So times 3.14. Then times the radius, which we said was 1. So 1 squared. And times 1 again. So now we just need to multiply all those together. Remember that 1 to any power is still 1, so 1 squared is 1. If we multiply these all together, we get, I should say this is approximate because we're approximating pi. So we get approximately 1.57, and our units would be cubic feet. So that's our volume of our half cylinder up at the top. So now we need the volume of the prism. Okay, so we'll start again with our formula. For the volume of a prism is capital B, which is the area of the base, times the height of the prism. So if we look back at our drawing, we can see here that our base is a rectangle. So we'll call 2 feet as our length, and 1 foot is our width. And then we're also going to need the height of the prism. Well, in this case, the height is right here, and that's going to be 3 feet. Okay, so the area of our base, since it's a rectangle, that's length times width. So we'll fill those in. Area of the base is length times width, so that's 2 times 1. And then we need to multiply that times the height. Right here, the height of our prism, which is 3. And if we multiply those together, we get 6, and again that would be cubic feet. Well, we said at the beginning that we need to take the volume of the cylinder plus the volume of the prism, add those two together. So that's going to be our last step here. So we'll take 1.57, and we're going to add to that 6. So we get 7.57, and again our units, we need cubic feet.